Imagine stepping into the exact same spot in a forest.
Mm-hmm.
It's, familiar wetland. It's quiet. It's peaceful.
Mm-hmm.
The trees are where they should be. The pond is reflecting the sky. But when you listen for the music, the really deep, complex song of the birds there, you realize something is just, wrong.
Something's missing.
Exactly. The entire musical tradition has just vanished. Not changed a little, not evolved, but completely wiped out.
And that dramatic scenario you just described is pretty much exactly what researchers found in a really fascinating study of animal cultural evolution.
So for this deep dive, we're looking at the thrush nightingale, Lousinia lousinia. It's a migratory songbird, and it's known for having just this astonishingly complex song.
Right, and the sources we have detail this incredible long-term project. They compared recordings from the very same place in southeastern Finland. It's an area near the Sikalahti Pond, over a span of 33 years.
33 years. So they had recordings from 1986, and then they went back in 2019.
And you have to remember, for a bird like this, 33 years is, it's several generations. Their lifespan is typically under a decade.
So we're talking about the great-grandchildren of the original birds.
Exactly. And their song is a learned cultural behavior. It's vital for mating, for defending their territory. And what makes this particular spot so special is that these males are highly philopatric.
Meaning they're loyal to their home turf.
They come back to the same breeding grounds year after year. So we're not just looking at some new group of birds that wandered in. We're looking at the descendants of the 1986 population singing in the very same place.
Which means the changes they found have to be local, generational. And that tells us something really deep about how fast a culture can, just fall apart and rebuild itself.
So our mission today is to track those shifts, to use the differences in their songs as evidence to figure out not just what changed, but maybe even why this local culture turned out to be so incredibly unstable.
Okay, so before we get to the bombshell finding, we probably need a quick primer on avian grammar. Because when we talk about a nightingale, we're not talking about a simple chirp. There's a system to it, a kind of syntax.
Yeah, the researchers had to break it all down into specific units. It's a hierarchy, from the small basic sounds up to these complex sequences. The foundation, the smallest building block, is what they call the syllable.
Okay, so a syllable is like a single note or a word.
It's more like a phonetic unit, the smallest distinct sound structure that's always repeated the same way.
I see. And then those syllables get strung together.
Exactly. They're strung together in a very specific conserved order to form what's called a song type. And for the thrush nightingale, the song type is defined by its ending. It has this really characteristic signature.
A signature, what does that sound like?
It's usually a loud, low-pitched sound they call a castanet, and that's immediately followed by this deep, rattling, broadband trill.
So that's the signature move. The syllable is the vocabulary, and the song type is the complete musical piece, the one you can recognize by that unique ending.
That's the cultural tradition right there. So the team compared 11 males from '86 with 10 males from 2019. They had over 1,500 songs to analyze, so it's a really solid snapshot of the local dialect.
Okay, so let's get into that cultural inheritance, because this is where the story takes a really fascinating turn. You'd assume, a great-grandchild bird would inherit some of its great-grandfather's greatest hits.
You would certainly expect some of those distinct songs to hang around, some persistence.
But that's not what happened.
No, the data completely defy that expectation. So across the whole study, they found 31 distinct song types, 18 back in 1986, and 13 in 2019.
Okay.
And here's the finding. There was a complete turnover of song types.
Complete turnover. Just to be clear, does that mean, most of them were gone?
No, I mean zero. Absolutely no shared song types. Not one single instance of that specific castanet and trill sequence from 1986 was found 33 years later.
Wow. Okay, so if the song type is the culture, then the culture just died.
Yeah.
It was completely replaced.
It was a cultural wipeout. At that complex level, yes. But, and this is where it gets really revealing, while the songs themselves vanished, the core language they were built from, the syllables, showed remarkable stability.
Really? So the building blocks stuck around?
A lot of them did. They identified 122 total syllable types. And remember, the song type sharing was 0. But for the syllables, 32 of those types were present in both 1986 and 2019.
So what percentage is that?
That's over 40% of the original 1986 vocabulary still in use 3 decades later.
That's a huge difference. The foundation is still there, but the building itself is completely different.
Exactly. It tells us that the individual units of sound are resilient, but the complex syntax, the rules for sequencing them into a meaningful song is just incredibly fragile.
Which makes sense. It's easier to remember a word than a whole paragraph.
Precisely. And this actually backs up older, shorter-term studies.
Yep.
Even within a single season, they saw high sharing of the basic elements, but much lower sharing of the full song types. This long-term data just confirms that the complex structures are always the first to go.
And this is especially weird when you compare it to its closest relative, right? The common nightingale.
Yes, that comparison is so important because it just highlights how plastic the specific thrush nightingale population is. The common nightingale has a massive repertoire, sometimes over 190 song types per male.
Wow.
And yet, studies have shown that some of their most common songs have stayed pretty much unchanged for 4 to even 9 decades.
So one cousin is like a cultural historian holding on to its music for a century, and the other reinvents its entire catalog every 30 years. Something really unique is happening at Sikalati.
It really is.
And it wasn't just the songs themselves that were different. The research also found these big quantitative changes. The way the birds organized their music, that changed too.
Right. It's not just what they sang, but how they sang. The two big things are that repertoire sizes shrank and the songs themselves actually got longer.
Let's start with the repertoire. So that's how many unique songs a bird knows.
Correct. And back in 1986, the males were, you could say, musical maximalists. They had significantly larger repertoires. The median number of song types was 8.
Okay, a median of 8.
By 2019, that median had dropped to 6, and some males only knew 4 unique songs.
So a definite reduction in their catalog. And that applied to the basic vocabulary, the syllables, too.
It did. The median number of syllable types dropped from 45 in 1986 down to about 38.5 in 2019. So fewer songs and fewer words to make them with.
But then here's the part that seems counterintuitive. They know fewer songs, but the songs they do sing are longer.
Significantly longer.
Yeah.
And not just by a tiny bit. The average song in 1986 was 5.0 seconds. In 2019, it was 6.1 seconds.
So that's more than a full second longer on average.
It's a 1.09 second difference. In the world of avian communication, that's a really substantial increase, and it immediately points to a change in their social interactions.
A change that's also backed up by how much they were sharing songs with each other. I mean, if they're interacting less, you'd expect them to share less of their repertoire.
And that's exactly what the data showed. They use a metric, the Jacquard similarity, which basically measures the overlap between two birds' song catalogs.
Like a musical Venn diagram.
Sort of, yeah. And in 2019, that repertoire sharing was significantly lower. It tells us the recent population is much less vocally converged. They're not all singing the local hits the way the older generation was.
And what about learning from your next-door neighbor? You'd think physical proximity would be the main driver.
You would, but surprisingly, for the 2019 population, it wasn't. The similarity of their repertoires was not related to how close their territories were.
Really?
Yeah, the males with the most similar songs weren't recorded near each other at all. That suggests that that dense, interactive neighborhood that usually drives song sharing just wasn't really there anymore.
Okay, so let's play detective.
Uh-huh.
We have a musical culture where the songs are all new, the repertoires are smaller, but the songs are longer, and there's less social sharing. What could possibly cause all of that to happen at once?
Well, the researchers considered a few scenarios. One is just slow, gradual change, what you'd call cultural drift. Errors just build up over generations.
Okay.
The other is a rapid invasion. Maybe a whole new population moved in with a different dialect and took over.
But do those explain why the songs got longer or why the sharing dropped? They seem to only explain the turnover.
That's the issue. And that's why the third idea, population dynamics, is the most compelling one. The researchers noted, just from their own observations, an apparently lower density of thrush nightingales in 2019 compared to 1986.
Fewer birds in the same area.
Exactly. And that one simple demographic shift could elegantly explain all of the changes they saw.
Wait, I'm not sure I follow. I think with less competition, they wouldn't need to work as hard. Why would they sing longer songs?
Ah, but that's the key. You're thinking about impressing mates, but a lot of singing is about male-to-male competition. If there are fewer rival males around, the risk of getting interrupted while you're singing drops way down.
Oh, I see. So they're not singing longer to show off. They're singing longer because nobody is cutting them off.
That seems to be the logic. When the social pressure is off, you can afford to stretch out your performance. It perfectly explains that 1.09 second increase.
That's a brilliant connection. And if they're interacting with fewer individuals in a less dense area, that explains the other changes too, right?
Absolutely. Less interaction means you have fewer tutors. There are simply fewer songs to learn and copy from your neighbors. That leads directly to smaller repertoires.
And, of course, less sharing between them.
And less sharing. So that single factor, a drop in population density, connects all three major observations. The longer songs, the smaller repertoires, and the decreased sharing.
It's just amazing how fragile these traditions can be. And sources say this wasn't even the first time this population showed this kind of volatility.
No, not at all. They mentioned that between 1980 and 1985, there was a big wave of immigration one year, in 1984, and it caused more than half of the song types to change in a single year. This local culture is just inherently sensitive to population flux.
Okay, so before we wrap up, what about other factors? We always hear about things like traffic noise or habitat changes affecting birdsong.
Right, and they did consider that, but they ruled them out as the primary cause here.
Why is that?
Because the parts of the song that are most sensitive to acoustic interference, those complex trills at the end, remained structurally very similar and were used just as often in both years. If the habitat had gotten noisier or denser, those are the first things you'd expect to change or disappear.
But they didn't. So all the evidence points back to social and demographic pressure.
It really does.
So let's synthesize this. What's the big picture here? We've looked into 33 years of birdsong and found a culture that's both highly complex and, well, extremely volatile.
We saw a complete wipeout of the complex song catalog. The specific traditions vanished. But the basic language, the syllables, partly remained. It just shows us that cultural evolution, even in what seems like a stable environment, can be startlingly rapid.
And that the most sophisticated, difficult to learn parts of a culture are the first to go when the social fabric changes. And it seems that change was driven by a simple decline in population density.
And that leads us to a really critical and I think provocative final thought for you to take away from this.
Okay.
In a world where wild habitats are becoming more and more fragmented and where animal populations are under so much pressure, often leading to these lower local densities, is the cultural richness of a complex learner like the Thrush Nightingale one of the first and most vulnerable things to disappear?
Wow. Is the loss of song diversity, this cultural wipeout, an early warning sign? A kind of leading indicator of deep ecological stress, maybe signaling trouble long before the species itself shows obvious signs of decline. That is a perspective worth thinking about the next time you hear a bird singing out in the wild.